Okay, if the menu on the side is bugging you, you can switch it off. You can see the whole screen. Also, if you insert your USB port or USB in here, you can take a snapshot of the screen using the print features. Save and recall, and you can go and capture it, nice for documents. Okay, now these scopes comes out with trigger features. It doesn't trigger itself, and you need to set in the trigger. So I'm going to use the built-in test function here to show you the trigger. Now, if you're not sure if the scope is working correct, you can connect up a channel to the test here, and it says that it will give out a -5 volt signal at 1 kilohertz. Okay, let's tune this in more, and if we bring our menu back and we say our coupling is on DC, your signal is right there and it's drifting now for some reason. Now, this drifting is your scope needs some reference point on this signal to make it stand still. So, you need to set the triggering level. Down here you'll see a voltage, and our voltage is now on 2.2 volts, and that is a comparator triggering on the signal. Now your signal is standing perfectly still. Okay, you can't do measurements on a signal that's running around. Right. Now, the scope is set on 5 volts per division, one block, 5 volts. 1 millisecond per division, one block, 1 divided by 1 millisecond is 1 kilohertz. Okay, now, as an additional bit of info here, this scope only has 8-bit ADC internally. So if you only have your signal showing small, this scope is measuring this whole range, but your signal is there. So it means your readings is not accurate. Okay, so rather always try and see your whole signal. Okay, it means your accuracy is nice, and do the same for your frequency version. If you see 2 waves, it's usually accurate enough. Okay, down here you will also see the scope will make an estimate of a frequency incoming, and it is around about 1 kilohertz like it should be. Okay, if you set this too small, this reading can become very inaccurate. Okay, always try to see 2 waves at least and make your signal as large as possible. It's like using a very small ruler to measure the size of a room instead of using the measuring tape. Right, so floating signals, you sort with a trigger, always try and see a large signal, and the amounts of blocks, 2.5 multiplied by 2 is 5 volts. Okay, 250 milliseconds, 1, 2, 3, 4. It's 1 millisecond, 1 kilohertz. Right. Now, more on the trigger. The trigger also has a menu. If you have multiple signals, if you're using channel 1 and 2, the scope needs to know on which channel it needs to trigger. Okay, currently it's set on channel 1. If we set this to channel 2, there is no signal on channel 2, there is a floating point, so our signal starts jumping around again. You can use the external trigger. Okay, we don't have one now. or it can trigger on the AC line, so the power incoming into your scope. So it will refresh every about 20 milliseconds. Then, okay, we're working on channel 1, so let's set it to channel 1. Then we have the kind of trigger, edge triggering. So currently it will trigger on the edge of your signal, or if there's a pulse kind of thing, not a solid frequency, it will trigger on pulse and then stop. It will halt the screen. Okay, let's keep it on edge. Now, you can choose if the scope should trigger on the rising edge of a signal or the falling edge of a signal. Switch it to falling. Now it triggers on the falling. Okay, so it takes that reference in the center of the screen. Then there's some modes. For all intents and purposes, keep it on auto. Okay. Nothing to lose in that menu further. Right. Now, sometimes you have a signal that it's only there for a moment because you need to push some kind of button or do something for your signal to work. That's when you can either use the external trigger, or if you see the signal, you can press the run stop button and it freezes the data that's on the screen at that moment. Okay, this is nice when you need to do some sensitive measurements.